Hello, sugar plums. It's me again, doing another video for you guys. Before I get started, I hope everybody's well and your family is doing awesome. You're having a great time at home while you're in quarantine. By the way, most of the students that I have live session with, they say they are completely and utterly bored at home, guys, okay? So take some time and enjoy this wonderful experience, guys, with your family members, okay? You may never have this moment again, and believe me, okay? Enjoy it now, because one of these days you might have to think back on this and think about how you handle the situation, okay? Words of wisdom for you guys. All right, so some announcements. Number one, the assignments, guys, the assignments, okay? You know what? Let me turn on the camera so you guys can see my face, okay? So, sugar plums, listen. There are many of you who aren't completing the assignments. What is up with that? Shazam! You guys need to do the assignments, okay? You have at least one assignment due every single week. We are still using Math Excel for school. Nothing has really changed for you guys because we've been doing the same thing since the beginning of the school year. The only thing that has changed is now we've completely transitioned to online assignment. So you guys are ahead of everybody else who wasn't doing these online assignments, okay? So why am I seeing so many of you not working on your assignments? By the way, okay, here's a little caveat. Many of you have worked way ahead, okay? So this part is not for you if you've already completed your assignments. I'm talking to those sugar plums who haven't done the assignments, especially those of you who haven't done a single assignment, okay? So every Friday, there's an assignment due. Furthermore, every Friday, you have an assessment due. It could be a test, it could be a quiz, okay? So this Friday, you have two assignments that are due, assignment number 25, as well as assignment number 26, plus quiz number 8. So you got 3 things due this Friday, okay? Now, next week, you're going to have one assignment due and the test for this chapter, which is chapter 7, okay? So guys, do your work, okay? Now, number 2, okay? If you know somebody who hasn't been doing their work, remember, what do I always say? Friends don't let friends fail, okay, sugar plums? You better find your friend, you better call your friend, Snapchat your friend, okay, TikTok your friend, send an Instagram message out there to your friend. You better get your friend to do his or her work, because nobody's going to fail this class. Everybody has to pass this class. In order to pass the class, guess what? You have to do your work, okay? So if you're passing and your friend is failing, what's up with that? Okay? Get your friend on those assignments, all right? Number 3, I am going to keep doing these videos for you guys and uploading the videos on YouTube on my channel. Right now, you know, I'm uploading all these math videos. My channel wasn't meant to be about math videos, guys, okay? It was about money, okay? And it was about traveling. So now I'm uploading a whole bunch of math videos. Well, whatever. All right? So I'm a multifaceted individual. So okay, so the videos are on YouTube. I'm going to send you the links, obviously. So make sure when you go in to do your assignment, put up the video and then go through your assignment and do it, okay? You, if you watch the last video, will notice I am actually going through every single problem and working it out just like I did in the classroom. So here we are, guys, online, and I'm doing the same thing for you. Obviously, I am using Zoom. I don't know if you guys noticed that, okay? Zoom was banned from the high school, but because you guys are not in the session with me, I can actually do a Zoom video and send it out to you, okay? So I love Zoom. I love zooming, Zoom, okay? Now, before I get to number 4, let me just say this, guys. I don't know if you noticed in the grade book, I started populating the zeros today, okay? Hopefully that will be the wake-up call some of you need for those of you who haven't done any of the assignments. Yes. So now your guidance counselors are going to find out. The deans are going to find out. So your phone is going to be, how do you guys say it again? They're going to be blowing up your phone. Okay. Last but not least, class of 2020, I feel you. I'm there for you. That is why I did the alma mater for you. I feel really bad, guys, but remember, you're going to have an awesome story to share with your kids and grandkids, okay? Go class of 2020. The last day for you guys is May 15th. Hang in there. Oh my gosh, I forgot to tell you guys, no final exam. You guys are not going to have final exams. So all you have to do is pass this quarter. Now, if you fail the last quarter, the third quarter, you have to make sure you get a C or better in this quarter so you could average out the grades to a passing grade, guys. Did you hear that? No exam. So which means the quarters, okay, are going to be averaged out. So make sure you get a C or better on this quarter right here if you fail the third quarter. Hello. All right. So that's all the announcements I had for you. So now I'm going to start the teaching, guys. It will not take that long. All right. So I am discussing the complex numbers. Okay. You guys commonly refer to them, excuse me, as the imaginary numbers. You don't need to be seeing me right now. So let me turn off this video because I keep turning around. Okay. I'm turning this off. There we go. All right. So the imaginary numbers, guys. Way back at the beginning of the chapter. By the way, guys, this is assignment number 26, okay? Lesson 7.7, all right? Now, way back at the beginning of the chapter, we encountered problems like this, the square root of negative 16. And back then, because we weren't discussing imaginary numbers, we basically said that this became a number that's not real. This number right here, it's not real. Now, why is this not real? I talked about it at the beginning of the chapters. I'm going to talk about it again. If you plug this into a calculator, guys, the calculator will give you an error message. Why? Because the calculator is not set up to take the square root of a negative value. It's impossible. Why is it impossible? The question you have to ask yourself is, can you take the square root of a negative number and get a value for it? Can you find a number such that when you multiply it by itself to give you a negative 16? Let's say we try negative 4. Negative 4 times negative 4, that doesn't give you negative 16, it gives you positive 16. Well, what if you had positive 4? Positive 4 times positive 4, obviously that's also positive 16. So no, because you cannot find a single number such that when you multiply it by itself to give you negative 16, we say this is impossible within the realm of real numbers. So that's why we said at the beginning of the chapter, this is not real. It's fake, okay? So what are the fake numbers? The imaginary numbers, guys, imaginary numbers, okay? So the reason why we are prevented to take the square root of negative 16 on the calculator is because of the negative. However, if we were to take the square root of negative 16 and separate it into the square root of 16 times the square root of negative 1, now we can actually take the square root of 16 because it's positive, which gives us 4. The square root of negative 1, let me use a different color here, is defined as the imaginary unit I. So the square root of negative 1 here would be replaced with I. Therefore, that square root of negative 16 now simplifies to 4I. And there you go, guys. That's how the imaginary numbers come about. So now the question is, okay, can you do some of these imaginary values? Can you evaluate them? For example, if you have the square root of negative 100, what do you get for that? Because it's a negative under the root. Every time you encounter that negative under the square root, guys, you have to change it to an I. So you take the square root of 100, that's 10. The negative inside the root becomes an I. Likewise, if you have the square root of negative 144, you take the square root of 144, that's 12. The negative under the root becomes an I. Well, what if you have something like this? Well, you know what? Let's do something a little bit simpler than that, and then we'll get to it. Okay, I'll come back to it. What if you have this, the square root of -5? We can't take the square root of 5. We cannot. But there's a negative under the root. So when there's a negative under the root, you've got to take it out and change it to an I. And then the square root of 5 remains. Guys, it's best to write the I in front of the radical. You don't want to write it after the radical so that it seems like it's inside the radical. So it's best to write it in front of the radical, okay? So now getting back to that square root of -8. Now, firstly, we have that negative under the root. So the negative, guys, will become an imaginary unit. Secondly, that 8 can be simplified. 8 is 4 times 2. 4 is the perfect square that goes into 8 evenly. So if you take the square root of 4, that gives you 2. And then the 2 remains under the radical. So that square root of -8 will simplify to 2i radical 2. Questions, guys? All right. Now, we're going to move on. A complex number. What in the world is a complex number? A complex number is a number that is written in the form of a plus bi. In other words, it consists of a real number part and an imaginary number part. So any number that's written in a plus bi, refer to it as a complex number because it's a mixture of real and imaginary. Now, here's an example, guys, a concrete example of a complex number, 3 plus 2i. So 3 is the real part, 2i is the imaginary number part, okay? That's a complex number. So now the next step is to see what we can do with these complex numbers. We can add or subtract the complex numbers. Add or subtract them, guys. Complex numbers. So when we're adding or subtracting the complex numbers, all you do is this, guys. You add or subtract real with real, and then imaginary value with imaginary value. Plain and simple. So you're just combining like terms. Combine like terms. That's all we're doing here, guys. All right. So I'm just going to do one example for you guys because I am going to be going through the problems very shortly. So I don't want to linger on this. Quick example. Let's say we have 3 plus 2i plus 5 minus 4i. So here we have 3 and 5, which are the real numbers. So we're going to add them together. We get 8. However, the 2i and the -4i, they're imaginary. So we're going to combine them together. 2i take away 4i leaves us with -2i. Guys, look at how easy that was. Okay, let's do another one. Number 2. 3 plus 2i minus 5 minus 4i. I would distribute the negative over the second parentheses. So I get 3 plus 2i minus 5 plus 4i. Then I would proceed to combining like terms. So to combine the like terms, we're going to do real with real. 3 minus 5. That's going to be a -2. And then imaginary with imaginary. So in this case, we're going to take the +2 and the +4, add them together. We get 6i. And just like that, guys, we're done. Okay. Questions? All right, make sure you guys use the I on the palette when you're typing in your answers. Okay, multiplication, guys. Now, for multiplication, here's another rule with the imaginary numbers. You have to remember, when you multiply I times I, it's going to give you I squared. Now, each I represents the square root of -1. In other words, that would be the square root of -1 squared. What happens when you square a square root? Well, when you square a square roots, they cancel each other out because they are inverses of each other. So essentially, this becomes -1. So that I squared, guys, is -1. It simplifies to -1. All right? So when you are multiplying, whenever you encounter an I squared, guys, you have to convert it to -1. If you leave it as I squared, it would be considered wrong, all right? So for the multiplication, the best way to do this is through some example problems. So I'm gonna start with some easy ones. So if I'm multiplying a real number times an imaginary value, I just multiply like I did with the real numbers, like the polynomials or something like that, okay? So you get 12i, that's it. But if I have 3i times 4i, I multiply. I get 12i squared, guys. This I squared right here, let me change the color. This I squared right here represents what? -1. So this would be 12 times -1. So the answer would be -12. So if you plug in 12i squared into the computer, that would be wrong. You got to plug in -12. Next, number 3, I am going to distribute, guys, okay? I am going to distribute 4i over 3 minus 2i. And just like with the previous problem, you just go ahead and multiply. 4i times 3, 4i times -2. So this is going to give me 12i minus 8i squared. Remember, I squared is equal to -1. Be careful with this. So we're going to keep the 12i. Now, the -8i squared is actually going to be -8 times -1. So when you multiply this together, what is it going to become? Well, you keep the 12i, and then the -8 times -1 is +8. This is perfectly acceptable. However, since it's not following the way you express these imaginary numbers, the format of these complex numbers, you might want to rewrite this in the format, guys, as in the real number first, followed by the imaginary number. Okay, it's better that way. But the computer would still give you credit for it, okay? All right, I'm gonna do 2 more examples of multiplication, and then I am going to move on to the assignment, okay, guys? By the way, I'm only going to do the problems up to number 17, I believe. After 17, they're very easy. All right, so I'm gonna multiply 2 binomials now. So I'm gonna do 3 minus 2i times 5 plus 4i. All we're going to do is FOIL, guys. This is the exact same we did with the polynomials. So we're just gonna FOIL. 3 times 5 is 15. 3 times 4i gives us 12i. -2i times 5 is -10i. And then -2i times 4i is -8i squared. Now, these two right here, they are alike, so you combine them, so you get 2i. Over here, the -8i squared is actually 8 times -1, which gives you a +8. But we're not done because the 15 and 8, they're alike, so we're going to combine them together. So the answer turns out to be 23 plus 2i, and that's it. Now, here's the last one I'm doing, guys, and then I'm going to switch over to the computer, to the assignment, that is. Now, look carefully, guys. What do you notice about these 2 binomials? They are almost identical to each other, except the signs are different in the middle. Now, do you guys remember what they're called? It starts with a C. Okay, I know I can't hear you. Okay, so I'm just gonna give it to you. They're called conjugates. They're conjugates of each other. I can't put the S in there. They're conjugates of each other. So because they are conjugates of each other, there's a quick way to multiply them. We multiply the first 2 terms together, which is 9, and the last 2 terms together, which gives us a -4i squared. And of course, guys, you can't leave it like that, because every time you find an I squared, you got to change it to a -1. So this would be 9 minus 4 times -1. So we get 9 plus 4, which is 13. And that's it. That's it. All right, guys. So now I'm going to go into the assignment. I'm starting off with problem number 2 because number 1 is so easy. Okay. Number 2, this one's easy too, but I'm still going to do it. Negative radical negative 121. So the opposite of the square root of negative 121. Now, the negative on the outside right here, guys, we're going to keep it. Just bring it over, drop it, negative. Then you're going to take the square root of negative 121. There's a negative inside the root. You know what that means? It means you have an imaginary. Square root of 121 is 11, and the negative under the root becomes an I. So the answer for this one is negative 11I. Number 3, we are just adding 2 complex numbers together. So you're combining like terms. So we do 8 plus 6, that's 14. We grab a different color. And then we do negative 7I plus the 3I. So that's going to give us a negative 4I. Just like that, you're done. Okay, next one is a subtraction problem. It is 5 plus 6I minus 6 minus 7I. So you want to go ahead and distribute the negative over the second parentheses, that minus sign. So it becomes a negative 6 plus 7I. Take this negative right here, guys. Distribute it. Distribute it. So now we combine like terms, okay? So we're going to combine the 5 and the minus 6 together. So we get negative 1. And then we're going to combine the positive 6I and the positive 7I. We get 13I. And that's it. Okay, next we're on to a multiplication problem. For this one, number 5, everybody, is negative 6I times negative 3I. By the way, guys, for those of you who will be watching this, who are watching it, if there's something I'm missing, something you're not, please just go ahead and comment, okay? And if you like the video, go ahead and hit the thumbs up, all right? Because I need to know whether or not these videos are beneficial. I need to know if you're comprehending what I'm doing. I'm trying to do something that's gonna help you, okay, guys? So getting back to the problem, I'm multiplying negative 6I times negative 3I. A negative times a negative is going to be a positive. I times I gives me I squared. You can't leave that I squared there. That's negative 1, guys. So the answer is going to be negative 18. Number 6, I've got 8I multiplied by 8 minus 4I. So I got to distribute this 8I over this complex number. So I take each term, the 8I, and I multiply it by each term in the parentheses. So I get 64I minus 32I squared. And so now you guys should be used to it by now. Whenever you encounter an I squared becomes negative 1. So negative 1 times negative 32 gives you positive 32. And write it in the complex number form, as in the real number first, followed by the imaginary number. Ooh, that's supposed to be a 6. Shazam. All right, guys. Next one. It is 5 minus 7I squared. As always, guys, I'm sure you guys know way more about YouTube than I do. You can turn on the caption. I even believe you can slow down, okay, the speed of the video. Because, you know, some of you complain all the time about how, Miss Althea, you're moving too fast. Shazam. Okay. Oh, my God. So guys, let's look. On this one right here, you have a binomial squared. In other words, the binomial is multiplying itself. So the simplest thing you can do is to write it out. The binomial times itself, and then just go ahead and FOIL, just FOIL, okay? I can see Sierra right now. Miss Alcira, hold on, Miss Alcira, okay? So distribute the 5. So you get 25. I'm just FOILing, guys. 5 times negative 7 is going to give you a negative 35I. Negative 7i times 5 is negative 35i again. And then negative 7i times negative 7i, positive 49i squared. Combine these two together, so we get 25 minus 70i. The 49i squared becomes a negative 49. But wait, there's more. We're not done. You got to take that 25, subtract the 49, guys. So you get a negative 24, and then bring down that 70i. There's your answer. All right, number 8, I am not going to do because it's another subtraction of two complex numbers. And I believe number 8 was just like number 5 or something. No, hold on a second. Let me double check, maybe number 4. Yeah, number 5 is just like number 4. So reference number 4, please. Oh, Shazam, I said the wrong thing. Number 8 is just like number 4, guys. Number 8 is just like number 4. So I'm not going to do that one again. So just go back to number 4. You're just combining like terms. Oh, Shazam. Okay, so number 9 is very similar to, I think it was this one right here. Number 6. So reference number 6 for problem number 9. Next one. Number 10. Ooh, we did not even chat about that one. Okay, I'm gonna chat about it now, but I really wanna leave it for last. Okay, guys, so here's the question. I thought I didn't put those on here, but it's in there, so let's chat about it. This one right here is a division problem, okay? It's a fraction. The main reason you have this problem is to go ahead and remove, eliminate, simplify the I from the denominator. Eliminate the I from the denominator. You're not allowed to have an I in the denominator. So because it's a single term with an I, to eliminate it from the denominator, you're going to multiply both the numerator and denominator by I. And the numerator and the denominator. So guys, let me go ahead and grab a different color here so I can go ahead and show you. So I'm going to multiply the denominator by I as well as the numerator by I. So the numerator will become 25i minus 6i squared, and the denominator will become 5i squared. Now remember, I squared is always equal to -1, so whenever you find an I squared, change it to -1. So this will become 25i plus 6, because -6 times -1, positive 6. And in the denominator, this will become a -5. Now hold up a minute. We can't have a negative in the denominator. We can't leave it there. Furthermore, the goal was to eliminate the I from the denominator. Did we accomplish that? Of course we did. It's now just -5. There's no I there. So now, guys, we need to write it in the form. How do we write it in the form of A plus BI? Well, we take each term in the numerator and divide by the denominator. Each term in the numerator and divided by the denominator. So -6/5 minus 5i. And there's your answer. All right. That wasn't too bad. If it was too bad, okay, if it was too much for you, just guys, slow down the speed, or, rewind it and do it a couple of times. Some of you, you know what, you might actually enjoy these videos because now you have something you can reference anytime if you forget something, okay? So next one, guys, is problem 11, which is multiplying two complex numbers together. 14 minus 7i times 2 plus I. So here you're simply foiling, guys. 14 times 2, that's 28. Then you do 14 times I, that's 14i. -7i times 2 is -4. Oh, Shazam, look at that. Okay, well, we'll take it. -7i times I is -7i squared. So these two right here, 14i takes away 14i, so they're gone. So that leaves you with 28 plus 7. Why is it plus 7? I can hear you, Sierra. So -7 times -1. Mariah, I can hear you too, okay? -7 times -1 is 7. You add them together, so you get 35 sugar plums. There you go. All right. Number 12. 5 plus 6i times 5 minus 6i. And of course, I'm sure you guys remember these. These are your favorites. These are conjugates of each other. And because they're conjugates, you multiply the first two, 25. Multiply the last two, -36i squared. I squared, guys, is -1. So this becomes 25 plus 36. And you add them together. So the answer turns out to be 61. All right. So now the next part of this, guys. We have to simplify an I raised to some power. All you need to know is the fact that I squared is equal to -1. So I'm just going to break this up into multiples of I squared. So this would be I to the second raised to the 6th power. Well, I to the second is -1. -1 to the 6th power is equal to what? By the way, guys, there are going to be 4 answer choices for these problems. Either the answer is going to be I, -I, 1, or -1. So which one is this one going to be? Okay, on a side note, if you have a negative raised to an odd power, you get a negative. If you have a negative raised to an even power, the outcome will be positive. Well, we have a -1 raised to an even power, so the answer is going to be +1. There you go. That's it. All right, guys, that was 13. So here's 14. Now for number 14, I've got I to the 33rd power. Now, be careful with this. You want to rewrite this so that you can write this in multiples of I squared. So I'm going to rewrite this as I to the 32nd power times I. So I'm just breaking it up, guys. I still have I to the 33rd power, okay? Because 32 plus 1 is still 33. Now, this right here, I to the 32nd power, I'm going to rewrite it in multiples of I squared. So 2 times what gives you 32? 16. Now, on this one right here, guys, let me finish it off with a different color because I'm color coordinating this, okay? I squared is -1. That is being raised to an even power. If you have a negative raised to an even power, it's positive. So the answer for this one is just I. There you go. Okay, so now we're back to repeating the same kind of problems. Now, number 15 is just like, let's see here, which problem was it like? 15 is like 11, guys. 15 is the same thing as 11. So for number 15, you want to reference number 11. And then number 16, oh, okay, that was way at the beginning. Number 16 is just like problem number 3. So reference problem number 3. And then number 17, which is what I was getting to, number 17, oh, that's easy. Guys, the question is this. Here's a right triangle, okay? This angle is 62 degrees. Find the missing angle. Shazam. That's insulting, really. And guys, just like that, I am done with the notes for assignment number 26. So hopefully this helps you with your assignment. I will see you on the other side of things, okay? I will see you soon. Take care, Sugar Plums. Bye-bye.